Hi, welcome to this session where we'll be discovering about Pig. We will be talking about what exactly is Pig, what is the requirement of Pig, and what are the different functionalities which we can achieve using Pig. So let's get started. The first thing is, if we talk about the volume of data, it has massively increased. On top of it, the variety of data has also increased. Traditionally, we have been using MapReduce for the same. But MapReduce is very low level. You have to perform operations using Java whenever you have to achieve certain functionality. Pig helps us take the advantage of MapReduce by using simple constructs. The very first thing to know about Pig is, it is a high-level procedural language. By procedural language, we mean it is the language which has got data flow at its heart. You have to define procedures like how are you going to analyze the data, the step-by-step activity. Unlike SQL, where you perform inner queries or subqueries, in Pig, everything works as a data flow. Pig has got its own language called as Pig Latin for the execution of the queries. Internally, Pig will form a directed acyclic graph which will contain all the actions which are going to be performed in the sequence. Moreover, whatever you write, it will consume the data from Hdoop distributed file system, and it will operate MapReduce on top of that. If you know something about Hive, you will see this as a similarity, like Pig and Hive both are basically wrapper or abstraction over MapReduce. But Pig has got a difference. It is different from the traditional SQL because it aims at data flow. And for this, it does not require any subquery or inner query. So the ultimate advantage you get is, you get rid of most of the Java programming of MapReduce. You get standard data processing operations like joining of data sets, ordering or filtering, performing group by operations. So the development time and the execution time is quite efficient, because whatever you write in the Pig gets translated into a very optimized MapReduce program. While designing Pig, there were 4 different philosophies which targeted at the development of Pig, which include, the first is, Pig should be able to deal with varieties of data, whether it is an XML file or a flat file, whether it is a JSON file or any other semi-structured file. It should have the capability to read diverse varieties of data. So we call as pigs eat anything. The second philosophy is, pigs survive in any environment. By survival in any environment mean, it should not be tightly bound with any framework. If it is able to read from HDFS, it should be able to read from any local file system or any different file system as well. If it is able to apply MapReduce for processing, it should be able to apply any other processing framework for the same. The third ideology is, Pig should be able to process the data very fast. That is, pigs fly. And finally, the fourth philosophy for the development of Pig was that they should be domesticated, which simply means if user want to add its own code or own functionality into the pig, you should be able to do that without much of a pain. So user-defined aggregates, conditions, transformations should be supported. So that leads to a better customization of the pig. Some typical use cases of pig include some ad hoc operations, data factory operations. By ad hoc operations, we mean any operation which comes quick, which is transient in nature. Mostly in the ETL process, wherever you extract, transform, and load, pig is widely used to clean the data, to prototype the data, as well as to profile the data using some sampling. We are going to take a look into some examples using pig, but before that, this is the quick review of what are the advantages of pig. It has many inbuilt functions. There is less lines of code. And if you are not coming from Java background, you won't feel any discomfort in pig. Before we talk about one example, let us discuss a data set. We have got a CSV data set called as geolocation.csv. It has got different fields like truck ID, the driver ID, what was the event. So basically, whenever a driver rides a truck, there could be different events like the truck is going normal, or the truck is unsafe, or oversped. So this is captured as event. What was the ID of the truck? What was the ID of the driver? This is also being captured. Apart from that, we also have information like what was the location in terms of latitude and longitude, the city involved, the state, the velocity of the truck. Moreover, there are a few more indicators in the data set. So this is our CSV file in which we have got thousands of records. We would like to process this particular data set for our example and see how pig can help us in the analysis of the data. The very first thing we are going to do is, since I'm using Windows operating system, I'm using Acadgild sandbox, which comes up with the Linux operating system, CentOS. The username and password is the same. It is Acadgild. So once you log in to the virtual machine, you will be able to take what is your IP address of the machine. However, taking the IP address of the machine is not mandatory, but it will facilitate us for further analysis using pig. If you go to terminal, you can type the command ifconfig and you can get what is the IP address of the machine. Make sure that while launching from the VM VirtualBox Manager, if you go to the settings, inside the network, it should be attached to the host only adapter. This is something you have to take consideration before starting the Acadgild sandbox. Once this is started, I am using a software MobaXterm. This software helps us to perform login to a different machine. So the activity is very straightforward. You can simply go to the sessions. You can either create a session using SSH session. You can give the host name, the IP address which you obtained, the port, and then you can click on OK to launch it. In my case, I have saved the session. So if you double click, I'll get a prompt. Here you can type login as Acadgild and you will be logged in. One simple way to access pig is type pig, then -x and local. Pig has got two interesting modes to communicate. One is the local mode and one is the MapReduce mode. In the MapReduce mode, it will interact with the HDFS for the data. In the local mode, it will interact with the local file system for the data. Local mode is good for testing, good for debugging, or better say a development purpose. MapReduce mode is there for the actual cluster execution. We will discuss for the local mode. The commands remain the same. So if you give pig -x local, it will launch in the local mode, else it will launch in the MapReduce mode. Once you type the command, your pig shell will come into action. This is called as grunt shell, where you have to specify your pig operations. We have our data set placed at this location, home, Acadgild, pig demo data set. You can verify. We have got a file called as geolocation.csv. This is the file we are interested at. First of all, this is a CSV file. So pig has got different methods to load different types of files. File can be JSON, it can be flat file. In our case, it is a CSV file. Let's try to understand how things are working. First of all, we will register a jar called as piggybank.jar. This jar is responsible for providing us different customized loader methods. We will discuss about line number 3. A is equal to load this particular file using something. Most of the construct might not make much sense right now, so let us try to elaborate on the same. First of all, we are going to load this particular file and we are going to use the CSV Excel storage to load it. There are 4 different parameters which it accepts. The first is what is the delimiter between the fields. Second is whether there can be multiple lines. No, in our case, every line is one complete record. What is the line ending? The line ending, a new line character of Windows and Unix are different. So we specify the type of line ending, which is Unix type. And do we need to skip the input header or not? If you see the data set, our first line contains the header. It is not the actual data. So we plan to skip the input header. Finally, it will be loaded into A. Here, A is called as a relation. A relation can be considered like a table of the RDBMS. A relation contains many tuples. A tuple can be considered as a record from the RDBMS. So the takeaway from here is there is a relation and there is tuple. A tuple is always present inside small brackets and it can contain diverse data types, like the first field can be string, second field can be a double value, decimal value, third field can be an integer. So it has got diverse data types as different fields. In Pig, the data types can be char array, which is like a string. It can be int, it can be double, it can be float, it can be long. So there are different simple data types available in Pig. Apart from the simple data types, we also have support for complex data types, like tuple is one complex data type. Similarly, relation is also one of the complex data types. So let us try to execute the first 2 lines on the grunt shell. You will see lots of logs on their screen. That's quite natural with Pig. Now, the next point is for each A, that is for each tuple of A, you would like to generate $0. Here the dollar means a positional character. $0 means the first field of the tuple. $1 will mean the second field, $2 will mean the third field, and so on. So you are creating one more relation B, which contains only the first field of the relation A. So let's come to the data set. So the first field is the truck ID. So for all the records, you are going to fetch only the truck ID. This is what line number 5 or the highlighted line is trying to do. The overall records are in thousands. Suppose you don't want all the records, you want to restrict yourself to some small number of entities or some small number of records, you can limit it. So you are going to create a new relation C which contains only the 10 elements of B. You are limiting B to C. Finally, there is a dump. Dump is something like to print on the screen. You want to display the content on the screen, you can use dump. So let's try to execute these 3 lines as well. Once you execute this, it will process internally and finally it will give you the result. So see, we are having 10 tuples. Every tuple is containing only one element, which is essentially the truck ID. This is what we were looking for. Let's try to proceed on the same line. Whenever you create any relation, say A, I'm going to clear my screen using Control L. If you want to describe the relation, you will see the schema for A is unknown. So we have worked with A, whose schema is unknown. So this is one of the beauty of Pig, that you can work with the data set even if you don't know the schema. But if you know the schema, it is a good optimization to specify the schema whenever you want to read the particular data. How we can do that? It goes very similar to that. You can register the jar. You can load a relation A from the file using the CSV Excel storage, giving all the parameters. Finally, you can use as. After giving as, you can specify the name of the field and you can specify the type of the field separated by a colon. Like the first field is truck ID, it is char array. The second field is driver ID, it is also char array. Similarly, it can be double, it can be int, depending upon the type of data it holds. Now, once you load a relation A like this, you can construct other relations from A by using the name of the field. In the first example, if you go to line number 5, we were using the positional operator. But if you specify the schema, you have the ability to access fields by their name. You can access by positional operator in all the situations, but you can access using the field name only if you specify the schema. So here we are going to construct a relation B, which contains the truck ID and driver ID, and then we are going to limit it to 10. Let's try to execute this particular block of code and see what do we get. Once you execute this, finally you will see there are 10 tuples which contain the truck ID and the driver ID which we were looking for. Let us go to the dataset again and we will see there is a segment called as velocity. For one driver, there could be multiple entries and there can be multiple velocities. If you want to take what is the maximum velocity corresponding to a driver, you can do that also. Such aggregations are very possible. The first 2 lines must be making sense till now. It is simply creating a relation from the file. Next, we are interested in the driver ID and velocity. So we project out, we take out only these 2 fields and create a relation B. After we create a relation B, we perform a group by on B by the driver ID, because we want driver ID and the maximum velocity corresponding to that particular driver. After we group by on the driver ID, we generate the group. Group is the driver ID on which you are performing the group by and the max of the velocity. And then finally we are going to dump it. Optionally, you may also write here like E is equal to limit D, say 10. And you can dump E if you want to restrict your entries to a small number of records or a small number of tuples. If you do so and execute the same, if you dump it, it will do the processing, which is the local MapReduce, and finally it will give you the entries like for a particular driver ID, what is the maximum velocity. this is what we were looking for. Suppose you have designed this application, the same activity with MapReduce will take a larger amount of time to do that, and again with higher lines of code as well. Suppose you realize at later point of time that you don't require maximum of velocity only. Apart from the maximum of velocity, you require minimum of velocity as well as the average of velocity for every driver. It's very simple. Just add more aggregates, like for every group is your driver ID. You want the minimum as well as average of velocity. If you want to restrict the result, you can give limit. You can use limit operator and specify the number of tuples you want. Finally, we are going to dump E. In the process, you will see the output to be modified than the previous one. Now you are getting list of tuples which contain the driver ID, the maximum, minimum, and average of the velocities seen in the data set. It's very simple to make changes in the Pig scripts. Later on, if you want that on the basis of the average velocity, you want top 10 drivers, like top 10 drivers who have got the maximum average velocities. Now, how to do that? It's again very simple. You can load the file into a relation, generate driver ID and velocity, group by driver ID and generate the group which is the driver ID and average of velocity. You can give the alias. The average of velocity can be called as avg_velocity. Next, you perform an ordering by the average velocity in the descending order so that the maximum average velocity will be on top and then it will go on decreasing. And then you can choose only the top 10 elements. If you try to run this, you will observe the output to be contained of the driver ID along with the average velocity, and you will notice like these are in the descending order. You can check. The first is 40.4625, the second is 40.375, and so on. It is in a decreasing order of the average velocity. So this was about Pig. What are the different activities you can perform using Pig? Additionally, you can store the result into file in HDFS or local file system. You can create your own UDF, and there are many more interesting stuff about the Pig. But we'll hold on till here itself. I hope this particular session gave you a head start into the domain of Pig, of what exactly Pig is and what are the things you can do with Pig. Thank you.